Hello, and in this final video on transformations we'll be looking at vertical stretches and compressions. So we're going to take a look at the absolute value function again, and we're going to look at how vertical stretches and compressions work on this graph specifically. So the graph of absolute value of x, again, remember, if you hit 0, you're at 0, you're at 1, 2 is at 2, 3 is at 3, 4 is at 4, 5 is at 5. If you're at -1, you're at +1. -2 is at +2, -3 is at +3, -4 is at +4, and so on. So we have a graph that travels up in this direction and down in this direction. Okay, so this is our absolute value function. Now, a vertical stretch or compression happens when they're multiplied by a value. If the value is negative, then it also reflects it as well as stretching it or compressing it. Now, the stretches happen when the value is larger than 1. So this is considered a stretch because every value of x that we put in there is then multiplied by 3. So in this case, 0 wouldn't be stretched at all because 0 times 3 is 0. But when we put 1 in there, this 1 value for the y gets stretched out to 3. So it goes up to this value here instead of 1. This value of 2 would be stretched up to 3 times that value, which would be 6. That would be 2, 4, 6. So it would go here. So this side of the graph would be stretched upward at a factor of 3. So it would be stretched up. All the y values would be 3 times as much. And this would happen over here as well. 1 would be at 3 and -1 is at 3 and -2 is at 6. So it would be stretched up on this side as well. So basically all the y values are multiplied, and that's called a vertical stretch. Now the other part of this transformation is a compression. So if the value that we're multiplying by happens to be less than 1, or if it's negative and -1/2, then it would be flipped over, reflected on the x-axis as well as being compressed. So in this case, our 1/2 here, instead of going over 1 and up 1, we'd go over 1 and we'd multiply that by 1/2, so it would only go up as a half value here. Where we went 2 values up here, that would be cut in half, so it would go through 1. 3 would go to 1.5. 4 would go to 2. So our graph would be compressed towards the x-axis by a factor of a half. So instead of going up the same amount, it would be half that amount going this way. So and it would happen the same on the negative side as well. It would have the same compression happening on this side. So it would also be half as high. Okay, so when you're having a 1/2, that's a compression, and if you're having a 3, then that's a stretch, and that happens when we multiply by the value. So my second example here of a compression, we're going to take a look at just a graph of a function, and we're going to do these. This is a stretch and a compression. So in a stretching value, you take each value of your graph and you multiply it by, in this case, 2. So this y value is 0, and when we multiply 0 by 2, you get 0. I'm going to take a look at this y value here. This y value here is 1, 2, 3. So it's going to go up to 6, 4, 5, 6 because it's multiplied by 2. So its y value is, instead of being at 3, it'll be at 6. All right, and this y value is 1.5, so it would go up to 3, 2, 3. We'll go through there. So this segment would be stretched up to this segment value because it's doubled. Every one of those values are doubled. Now, since this is a flat piece of segment, it just gets doubled. It's going to be also a flat piece of segment, just twice as far away from the x-axis. So instead of having this be flat at 3, this one's going to be flat at 6, 2 times as much. And then this one is going to drop down to this point, because this point, when you double the height of 0 here, you're going to have the same value of 0. So you can also look at this. This is going to be at 2, so it would be at 4 here. So there's 2, there's 4, it would cross through here. And this is 1, so it would cross through 2 here. So this would come down through that point and end at 0. So this would be a vertical stretch of this green part of the graph. And we do the same thing on the negative side. This is 2. This value here is 0, so we'd start there. But this value here we know is -2, so we double it and we get to -4. So this piece would go straight line from there to here, because each of those pieces were doubled. This would have a little segment, because this is at -2, so times 2 of this little segment ends here. So in this case, we would have this piece being 1, so that at that part it's going to be 2 right here, twice as tall right there, and then it would travel through that point and intersect with this. So this graph has been stretched by a factor of 2. The blue graph has. Now the red graph here is going to be compressed by a factor of 1/3. So instead of coming up here we're still going to be at 0 anytime at 0. So this compression one is still going to have points here, here, and here, because those values are 0, and 0 times 1/3 is still going to be 0. So we're going to have those 3 values being common in all of the graphs. But instead of going up to, at this point 2, we're going up to 3, so it would only go up to 1/3 of that, which would be 1. So it would travel from here to there up to that high value of 1. Then it stays constant until this point, and then it travels back down to 0 here. So this is a compression of 1/3 from the green graph. And the same thing happens here. The value here happens to be 2, so if we take 1/3 times 2, we're going to get 2/3. So it's going to be about to that point at where it reaches its point here of -2. We're going to multiply that by 1/3 and get -2/3. So the point here to this point is connected. It's flat here, and then it goes down towards the 0 value here. So this red graph is a compression of the green graph by a factor of 1/3. So to summarize again, vertical stretches are when we have a number and multiplied in front by a value that's larger than 1 or smaller than -1. If it's negative, it's going to reflect as well as be stretched. And then our compressions are going to happen when our numbers are less than 1, but greater than -1, so somewhere in between that. But we couldn't have a 0 value because then we wouldn't have a graph there. And that's the last transformation on stretches and compressions.